Hello, everyone. This is always so awkward to start, so what's it called? We are going to do the TCP IP models OSI layers today, and hubs, switches, and routers. If we have time for other things, we're going to go ahead and add those. If not, then we're going to stop there. And yeah, so I'm going to start screen sharing. I don't know where Abdul is. I'm still trying to find him. Hi, everybody. Good. How are you guys doing? Raj, you want to hop on Zoom with me? Do you want me to send you the legit link? Or here, wait, let me do this. Please. Thanks, bro. Here's the meeting password. Five 707. There you go. Oh, okay. All right, sounds good. All right, well, let me start screen sharing. And oh, maybe I should open it first, right? Okay, 1 second, you guys.
Go to Monday.com and start tracking any project or workflow in minutes. Yeah, minutes.
Welcome to the IT free training video on.
The only thing I need from you guys is to
Go
let
to
me know.
Monday.com and start tracking any project or workflow in minutes. Yeah, minutes.
Hold on, this is going to be so confusing. Wait. Okay, there you go. I need you guys to let me know if you will be able to hear, or if you're able to hear the video. Listen, you guys, it's Sunday. My brain's not working all that great. All right. Let me share my screen. Oh, No. Share computer sound. Okay, I think I'm doing it right. Let's see. Can you guys see? Oh, so unorganized paper. 1 second, you guys. Can you guys see?
Well,
All right. It's because I'm still sleeping, Rod. That's why I look different. Can you guys? Oh yeah, you can't see my screen. All right, I'm gonna start. Message me on YouTube if you. I'll be keeping an eye out on the YouTube chat. Let's do this.
On the OSI model. This video will look at the OSI model and in particular how it relates to the Internet Protocol.
Sorry, can you guys hear clearly? Can you let me know in the chat if you can hear clearly?
The OSI model was first developed in the 1980s. It is a conceptual model aimed at standardizing network communications. The model is not implemented in its entirety, but it is still referenced today. As shown, the OSI model has 7 different layers. Each layer is directly linked to the layer above and below it if a layer exists. As data travels down the OSI model, each layer adds additional information. This continues until it reaches the last layer. It is then transmitted across the network. Once the other side receives the data, the process is reversed. You can see how each layer requires the layer or layers adjacent to it. Also, it's not possible to skip a layer. All communication either starts at the top layer or is received at the bottom layer. So what does each layer of the OSI model do? At the top is the application layer. This layer provides the application programming interface. The next layer, presentation, is responsible for data formatting. This includes encoding, encryption, and compression. The next layer, session, is responsible for connecting and reconnection of the network connection if it is lost. This also includes authentication of the connection. The next layer, transport, manages packet size and the resending of data if it is lost or corrupt. The following layer, network, routes data between different nodes in the network. The second to last layer, data link, is responsible for flow and error control. For example, ensuring more data is not sent out than the local network can handle. The last layer, physical, communicates directly with the network and is responsible for transmitting data on the network. As stated, the OSI model is a conceptual model and not directly implemented in modern networking, but it is referenced from time to time. To demonstrate this, I will now compare it to the TCP model. TCP stands for Transmission Control Protocol, and IP, as we know, stands for Internet Protocol. A number of protocols are used to make Internet communication possible. These protocols are grouped together under the name TCP/IP. Nowadays, you don't hear this name so much. Generally, you will just hear IP4 or IP6, but it is still valid. As you can see, TCP/IP has 4 different layers, as opposed to the 7 layers of the OSI model. It is shown as an exact fit. However, in reality, it does not fit the original OSI model exactly. The application layer maps to the first to third layers of the OSI model. Transport is a direct one-to-one mapping. The Internet layer maps directly to the network layer, and the last 2 layers of the OSI model map to the network access layer. Even though there are only 4 layers, each layer can be broken down further. As seen here, at the application layer is a number of different protocols. You can see how software will generally use protocols to access services on the Internet. The protocols themselves will access the transport layer. At this layer, there is a choice of TCP and UDP. TCP stands for Transmission Control Protocol. TCP gives reliable transmissions. If a packet is lost in transmission, the protocol will notice it has not arrived and request a resend. In contrast, UDP, which stands for User Datagram Protocol, is unreliable transmission. If a packet goes missing in transit, it is not resent. Think of UDP like mailing a letter. Once you mail the letter, you have no idea if it will arrive at its destination. The next layer determines if IP4 or IP6 is used. At the bottom is the device driver, which communicates with the network. The most common type is Ethernet. However, any other network device is supported. You can see how TCP/IP is very modular. This makes it easy to add additional protocols and add additional hardware when they are developed. I will now have a look at how the OSI model may get referenced today.
Robinhood is an investing app that lets you buy and sell stocks and ETFs, all commission-free.
The first device I will look at is a Layer 1 device. Remember that the OSI model refers to the first layer as physical and controls the transmissions at the bit level. Examples of Layer 1 devices are repeaters and media converters. A repeater essentially extends the limits of a network by boosting or recreating the network signal. A media converter, like the one shown, converts a particular network type to a different type. In this case, the media converter converts a fiber signal to an Ethernet signal. Layer 1 devices are very simple devices. The next layer I will look at is the data link layer. This performs flow and error control on the physical link. Examples of these are switches and bridges. Switches, like the one shown, allow multiple devices to be connected together on the same network. They differ from Layer 1 devices in that they can perform some management of that data that goes through them. For example, if a packet is sent to the switch, the packet will only be sent to the port that contains the device that packet is destined for. Layer 1 devices, in contrast, simply repeat the data that comes in from one port and replicate it out the other port. A bridge is a Layer 2 device that connects 2 networks together. For example, connects wireless to wired network. It is different from a media converter in that it inspects the data before sending it. For example, data that does not need to be sent to the wireless won't be. In contrast, a Layer 1 device will repeat everything that is transmitted to it. Next, I will look at Layer 3 devices. These devices work on the network layer of the OSI model. Layer 3 devices have the ability to route traffic between networks, so routers are considered Layer 3 devices. Also, certain switches have the ability to support routing. Shown here is an example of such a switch. It looks just like a regular switch, except it has routing ability. The advantage of using such a device is since the routing is performed in hardware, it is quite fast. The last layers that I will look at are 4 to 7. Usually, hardware manufacturers don't sell devices marketed under these layers. Which device fits in which layer tends to be a bit blurry. Devices that are considered layer 4 switching tend to be layer 3 switching devices with more features. The term layer 4 switching does not tend to get used that much. Essentially, it means that the devices can route traffic based on what type of traffic it is. In many cases, this is used to prioritize certain traffic over other traffic, for example, routing web traffic before video traffic. Layer 7 devices tend to be devices that can inspect protocols. For example, they can inspect HTTP. For example, some firewalls are considered layer 7 devices since they can inspect packets at the protocol level for certain types of attacks.
Wait, did it just say that some firewalls can be considered HTTP? Did I hear that incorrectly? The people in the YouTube chat are so funny. Raj just said, "Girl, can you feel my TCP segment number? Because I'm feeling a connection with you." All right, let's go back to this until I get a answer. Oh, I didn't know that about firewalls at the HTTP level. Cool. Thanks, guys.
Most applications work at layer 7, for example, an email server. As I said, devices don't tend to be marketed using these levels, so it is more having an understanding of which level the device may fit best. That covers it for this video of the OSI and TCP models. I hope you found this video useful. For more videos, please see our YouTube channel or webpage. Until the next video, thanks for watching.
My goal for
How do I do this so that it's not showing? Okay, let's move on to the next one. So some firewall, Raj says that some firewalls work on the lower level and some work on web-based. That's interesting. I literally had no idea. Okay, so we're gonna do, I think we're gonna do more than just these 2 videos today actually, because these are too short. So by the way, I really like this channel. What's his face? Whoops, wrong one. Yes, I like my channel too, you guys. No, but seriously. I really like this channel. He explains things very well. Power Cert animated videos. He's pretty cool. So let's start the next one. Oh my God, yeah, I love Dr. Todd Grande. He's so interesting to watch. Anyway, I really need to remove all that all that YouTube history stuff. Raj, we didn't really do the lab for the packet tracer. I haven't even had a chance to look at it, honestly. Yesterday I had to go to a dinner after the live stream. So I'm thinking maybe we can do it tomorrow or the day after. We can do the packet tracer. Or maybe if I can figure it out by tonight, we can do it tonight. Let's move to hub switches and routers. And I really need to figure out how to stop the delay between YouTube and Zoom. It's really bothering me. But anyway, that's not for today. So we're gonna do hubs, router, and switches. Let's go.
About the difference between a hub, a switch, and a router. Now, all 3 of these devices are similar, but there is a difference in the way they handle data. So we'll first talk about a hub. Now, the purpose of a hub is to connect all of your network devices together on an internal network. It's a device that has multiple ports that accepts Ethernet connections from network devices. Now, a hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where the data is supposed to be sent. And that's because the only thing a hub knows is when a device is connected to one of its ports. So when a data packet arrives at one of the ports, it is copied to all of the other ports. So all the devices on that hub sees that data packet. So again, a data packet comes into one port, then the hub will just rebroadcast that data to every port that has a device connected to it. So even if this computer here only wanted to communicate with this computer over here, these other computers would still receive the data even though the data was not intended for them. So when this happens, it not only creates security concerns, but it also creates unnecessary traffic on the network, which wastes bandwidth. Now, a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these physical addresses, called MAC addresses, in its table. So when a data packet is sent to a switch, it's only directed to the intended destination port, unlike a hub where a hub would just rebroadcast the data to every port. So as an example, if this computer here wanted to communicate with this computer over here, the data packet arrives at the switch, and then the switch will look at its table of MAC addresses and matching ports and deliver the data to the correct port. And then the data packet would only go to that computer. So that's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. So as a review, a hub only detects that a device is physically connected to it, and a switch can detect specific devices that are connected to it because it keeps a record of the MAC addresses of those devices. Now, hubs and switches are used to exchange data within a local area network. For example, such as in your home network or in a business. They are not used to exchange data outside their own network, such as out on the internet. Because to exchange or route data outside their own network to another network, such as out on the internet, a device needs to be able to read IP addresses. And hubs and switches do not read IP addresses. So that's where the router comes in. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the router inspects the data's IP address and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway of a network. So here we have a private network with its router, and we'll refer to this as the red network, indicated by the red colored screens on the computers. And over here you're going to have different data packets, indicated by their different colors, which represents different IP addresses, and they are going to be entering the red network's router from the internet. Now the router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network because their IP addresses were not meant for this network. Now here is an expanded view of routers over the internet. There are 4 networks here, indicated by their different colors, And each network has their own router, along with their hubs or switches and their computers. So right now, as you can see, each network is just exchanging information within their own network. Their data is not going out on the internet, so they are not communicating with other networks. They are just exchanging data within their own network using their hub or switch. Now let's go ahead and exchange data between different networks. So let's say, for example, that this computer here on the red network wants to communicate with a computer here on the blue network. So for this to happen, the data packet has to leave their own network and go out on the internet. So the computer sends their data, and it goes to the network's router. And once the data packet reaches the router will look at the IP address of the data packet and then forward the data out on the internet to the next router, and then make its way to the blue network's router, and then to the intended destination computer. So in a nutshell, this is how routers work. So in conclusion, hubs and switches are used to create networks, while routers are used to connect networks.
Okay, let me stop sharing. Oh God, I hate when I do this. Here it is. Okay, let me stop sharing really quickly. Share me video. And let's do this really quickly. Sorry, I just got a message on the chat. All right. So I wanted to go over, so I'm not going to go over the TCP IP models because there's a few things that I would like to understand more on them before I go ahead and speak about them. Actually, Nick, would you like to do that? Would you like to go over the TCP IP models? Are you familiar with it? Nick is ignoring me. Okay, so Nick is ignoring me. So
sorry. It's because I'm with my family right now. So
no. You're in no rush. How dare you be with your family? Don't you know it's the only life you can have? All right, so let's go over routers, switches, and hubs. That's really confusing to me because I can never remember which one does which. So as per my memory, just kidding, my notes. Routers, let me start with switches actually. Or no, let me start with hubs, sorry. Hubs connect devices together on internal networks, multiple ports, not intelligent. It sends data packets on, wait. Only detects that a device is connected. I'm not going to say where it sends data packets on because like I said, I need to review that part. So switches are similar to hubs. You can have multiple. Hubs are never used in the real world, says Raj. Switches are intelligent. They learn physical addresses. You know what? Nope, I'm not going to do a review because these notes, I need to go over them before I review them. I thought they were legit. Let's move on to the next video. And we can do reviews when like pros are here because the only thing is I don't want to give people incorrect information. That makes me really anxious. So I prefer to wait. Sorry, you guys, not so much fun with just me. But But yeah, like if I explain something to people and like it's the wrong thing and then they learn it, you know what I mean? I don't want to do that. So let's do Ethernet cables, UDP versus STP, straight versus crossover, Cat5, Cat5e, 6, 7, 8 network cables, and then we'll do half duplex versus full duplex. Un momento. I know, man. I know, man. I used to teach kindergartners. I used to teach children how to read and write English, you guys, when I was 18. Can you imagine? I used to be a teacher. All right, let's open this. Let's go ahead and share the screen, shall we? By the way, I'm not trying to ignore anybody who's sending messages. I just, it's very hard for me to see the messages. I'm really confused. Hold on, you guys. Okay. It's really hard for me to see the chat on Zoom while I'm streaming these.
My computer's possessed. The numbers are literally changing right in front of me.
I'm not an a-hole to YouTubers. Moving on.
Hello everyone. In this video, we're going to talk about Ethernet network cables that are used in local area networks, and I'm referring to twisted pair cables. These are the Ethernet cables that you'll find as you connect your computer to your router or modem so you can have internet access. One end of the cable plugs into your computer's network interface card, and the other end plugs into the network port of your router, switch, or modem, depending upon what you're using. Now, Ethernet twisted pair cables come in two different types. The first type is unshielded twisted pair, which is by far the most common type of cable that is used today. Unshielded twisted pair consists of 4 pairs of color-coded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of network cable is what most people use in their home or business. And the second type is shielded twisted pair. Shielded twisted pair is very similar to unshielded twisted pair, except that it has a foil shield that covers the wires. And this shielding adds an extra layer of protection against electromagnetic interference leaking into and out of the cable. This type of cable is mainly used for industrial purposes and not so much in a home or business. So if you were the kind of person that is going to make their own custom cables for your network, typically you would buy a bulk roll of twisted pair cable, and then you would have to wire them correctly and then attach RJ45 connectors to each end. So to do this, you would have to remove the protective sheathing at each end of the network.
So I just want to pause here for 1 second. I actually asked like the pros if we would ever have to do this for help desk, and they said no, you would just order new wires. Because I was like, oh my God, how am I going to do this? I don't know how to do this stuff, but there you go.
Network cable to expose the wires. And this is done by using a cable stripper. The cable is inserted into the cable stripper, and then the outer sheathing is removed to expose the wires. And then you would insert the cable into a wire crimper to attach an RJ45 connector. But before you attach the connector, the wires in the cable have to be arranged in a certain order. And that order will be different depending upon the purpose of the cable. So for example, the most common types of twisted pair cables that are used in a local area network are straight and crossover cables. And these two cables have two different purposes. So let's talk about the wiring order that these twisted pair cables use. And there are two different wiring standards that are used. One standard is called 568A, and the other standard is 568B. And on the screen you can see the wiring order for both the A and B standards. The orders are based on the color of the wires. So for example, the 568A standard is wired in this order: white, green, green, white, orange, blue, white, blue, orange, white, brown, and brown. And the 568B standard is wired in the following order: white, orange, orange, white, green, blue, green, white, brown, and brown. So the only difference between the A and B standards is the green wires are swapped with the orange. And it doesn't really matter which standard you use. Both standards do the same thing. But here in the US, most people use the B standard. So whether you choose the A or B wiring standard, if both ends of the cable are wired using the same standard, then this is known as a straight cable, which is also known as a patch cable. A straight cable allows signals to pass through from end to end. This is the most common type of cable that's used in local area networks. A straight cable is used to connect computers to hubs, switches, routers, or modems. Or in other words, it's used to connect dissimilar devices together. So as I said before, this is by far the most common cable that's used on local area networks. So these two straight cables here do the exact same thing. The only difference is that one cable is wired using the A standard and the other one is wired using the B standard. So let's talk about a crossover cable. Now a crossover cable is also used on local area networks, but it's not as common as a straight cable. A crossover cable is created when both ends of the cable are wired using the two different standards. For example, one end is wired using the A standard and the other end is wired using the B standard. Crossover cables are used to connect two similar devices together. For example, crossover cables are used to connect two computers directly to each other without using a hub or switch. And they can be also used to connect hubs to hubs or switches to switches. So they are used to connect two of the same devices together. Now, in addition to talking about the different types of twisted pair cables, we also have to talk about the categories of twisted pair cables. And these categories are called Cat 3, Cat 5, Cat 6, and Cat 7. And the difference between these is a maximum speed that they can handle without having any crosstalk or interference. The numbers of these categories represent the tightness of the twists that are applied to the wires. And as you can see on the illustration of the categories and speeds of the different twisted pair cables. So as you can see, the speed ranges from the lowest category, which is Cat 3 at 10 megabits per second, and all the way up to Cat 6A and Cat 7, which has speeds of 10 gigabits per second. Now most networks today would use at least Cat 5e on their networks, because most networks would be running at least at gigabit speeds. So Cat 3 and Cat 5 are slower than gigabit and are pretty much obsolete today. But of course, if you're running a network that can handle 10 gigabit speeds, you would have to use Cat 6A or Cat 7 on your network. But even if you have an older network that's running slower speeds, you can still use Cat 7 because it is backward compatible. Cat 7 is actually a shielded twisted pair version of Cat 6A. And finally, the latest version is Cat 8. Now, Cat 8 is the ultimate copper cable. It's a shielded twisted pair cable which has a delivery speed of 40 gigabits per second up to a distance of 30 meters, which is 4 times faster than Cat 6A or Cat 7.
This channel is actually really cool. I'm going to go ahead and share it in the chat because I like the way he explains things. Like, I really appreciate the way he explains things. All right, let's do half full, half duplex versus full duplex. Heife doesn't speak English today.
Annette, that groundhog's back.
Okay.
He's walking towards the door. Look at that. I guess it's Groundhog's Day in more ways than one, right? Did you hear my joke? I said, because the groundhog's here, it's...
Hello everyone. In this video, we're going to talk about a couple of different transmission types that are used in networking, and those types are half duplex and full duplex. So let's talk about half duplex first. So in a half duplex network, you have a point-to-point system where two devices are connected to each other using a network cable. And these devices can communicate with each other in both directions. But in a half duplex, they can only communicate in one direction at a time. They cannot communicate in both directions at the same time. So if computer A is sending data to computer B has to wait until computer A is done before it can send data to computer A. So data flows in one direction at a time. The two computers have to take turns when they send data to each other. So half duplex is just like how walkie-talkies work. With walkie-talkies, a person has to press a button if they want to talk to transmit their voice to the other person. And while the button is pressed, information is only going in one direction. So they can't hear the other person while they're transmitting their voice. They would have to release the button in order to receive the other person's transmission. Now full duplex is better. In a full duplex, the two devices can also communicate in both directions with each other, but the difference is that they can communicate in both directions at the same time, which gives full duplex an advantage over half duplex. Devices can send and receive data simultaneously. So as a result, because it sends and receives data at the same time, a full duplex system has double the bandwidth of half duplex. A good example of a full duplex would be telephone communication. When you talk to somebody on the phone, you can talk to and hear the other person at the same time. So you don't have to wait to do one or the other. You can talk and listen simultaneously. So as a comparison between half duplex and full duplex, you can use an analogy of cars on a highway, where you have cars that travel across an area. So in a half duplex, the cars would all have to share a single lane on the highway, and that lane only allows traffic in one direction at a time. The cars on the opposite sides of the highway would have to wait their turn to use that lane to get to their destination. And since it only has one lane, collisions do happen from time to time. And that's why in a half duplex network, it needs a traffic cop to regulate that lane to tell cars to wait their turn. And in networking, this traffic cop is called CSMA-CD, or Carrier Sense Multiple Access with Collision Detection. And this is an access method that's used to help avoid collisions and to also respond correctly if a collision does happen. And if you're not familiar with what CSMA-CD does, I'll put a link at the end of this video to explain what that is. But in a full duplex, the cars don't have to wait, because you can compare a full duplex as having a two-lane highway. Each lane is dedicated for a direction. The cars that are traveling in the opposite directions have their own dedicated lane as they travel to their destination. And so, as a result, since each direction has their own dedicated lane, it avoids collisions and there is no need for a traffic cop. Now today we use full duplex networks. A main reason why you would see a half duplex network today is for older legacy equipment that can only be used in half duplex mode. For example, if a network is still using hubs instead of switches, because hubs can only operate in half duplex mode and not full duplex, which is a main reason why hubs are obsolete today and you can't even buy them anymore. So thank you for watching this tutorial on the difference between half duplex and full duplex. Please subscribe and I'll see you in the next
I like the analogy that he used with like, that's how I remember half duplex and full duplex. Not the car one, more than I remember the walkie-talkie one. Maybe because I'm old. Let's move on to the next one. Did you guys know I could speak in a British accent? And no, I'm not making fun of British people. Oh, Stephen, it's you. Stephen, would you like to hop on the Zoom? Let me share the Zoom link. There you go, Stephen. I have added the Zoom link to anyone also who wants to jump on. Actually, since Stephen is here, maybe I can bother him about the TCP IP if he is in the mood to explain stuff. Stephen, will you hop on the Zoom, please? Or are you busy with Troy? Oh, wow, okay. Sorry, there were so many people in the waiting room. I'm so bad at this YouTube stuff, you guys. Hi. Hi, pros. I'm in the mood to explain stuff. Hello, Stephen. Hello, KevTech. Hello.
I'm here. Hi.
Raj, if I won't offend anybody, I will talk in an Indian accent.
Oh, here we go.
No one will be offended. How are you?
How are you guys doing?
How are you? We are, so we just watched.
I was watching.
Maybe four videos.
Me and Troy were watching at least one video. Now he has on Polar Express. So you got knocked out.
Oh man. Oh man, Troy, I thought we were friends.
Well, not like when it comes to the trains.
Yeah, no, trains win.
Trains your second fiddle.
So we did TCP IP, and then we did routers, hubs, and switches. And then we did UTP versus STP and twisted pair cable. Well, that's what UTP is, hey fun. And then Cat 3, Cat 5, Cat 5E, up until Cat 8. Hi, Kevin.
He has his freaking Windows XP background.
And then we did half duplex versus full duplex.
Hello?
Hi.
Hello? Hello, Governor.
Hello.
Hello, mate.
How are you?
I am doing well.
Are you?
Yes.
Did you know that I could speak with a British accent?
You can. Cheerio.
Cheerio.
How you guys doing?
Good, how are you?
Good, good. Did you get pizza?
I didn't get my pizza yet. Stop. So yeah, I'm gonna get my pizza like at night. And I'm gonna send you guys pictures just so you're what do you say? Your soul is at ease and you guys know that I have eaten pizza today. I actually haven't had pizza in like 2 weeks. Anyway, so yeah. I don't know. Do you guys, since there are pros here now, does anyone want to explain the TCP IP models?
You mean the 7-layer OSI model?
Well, there's two. There's OSI and there's TCP IP.
So the 7-layer OSI model, basically.
No, there's two.
There's TCP model, which is 4 layers, and then I guess the OSI.
Oh, yeah.
Kevin, go ahead, go for it. I mean, that's a whole It's a mouthful right there. I mean, you should really bring up a graph.
Okay.
Like
Wait,
Please do not throw sausage pizza away.
Yeah.
hold on, let me do
And
this.
you gotta have some kind of thing like that to remember it. Unless you have a photographic memory. Hey, Kev, one thing I do want to ask you, I'm rattling on my brain right now. The user accounts control. When you're on another person's computer and that user accounts control pops up and it's asking for credentials to get past a point where you have to need to load up an application, when you put in, where is that box coming from? That's coming from that's coming from the operating system itself. But what's it looking for? The local administrator on the machine or on the domain controller, some kind of rights? What exactly is that box looking for to fill in?
Talking about like when you install a program
Mm-hmm.
and you have UAC.
Yes.
And then UAC prompts a domain. It says like the username and password. It says /domain of or whatever. Because some of them pop up and it says like username and password and this is domain. And then we'll see like the domain of the company or whatever. And then you would put, typically for that, you would put your Active Directory admin account password for that to install it. You wouldn't do anything else.
If you knew the local administrator account for all the machines inside of your environment, could you use administrator blank password?
You can. I've done that before. Yeah, you can. You do the dot slash admin and then put the password in. It'll change it to a local instead of a domain with the user prompt, the USC prompt.
But that isn't, so either it's going to look for local or for the domain or for an account on the domain that you have rights to load up software. So it's going to look back to the domain controller going, even though you never logged on that machine before, it's going to look through the network and go back there and go, oh, wait a minute, this account does have rights?
Yeah, that's basically what it is. It's going to go straight to the domain controller and look for that username and that password. It wouldn't go anywhere else unless the computer is not on a domain, then it wouldn't do that. It would just go to the regular account.
And when it's not on the domain, you need to know the local administrator account and password.
Yeah. And then you come across this problem sometimes where an install installs the software on the computer and it installs it in the wrong location. It installs it on app data on the admin account instead of app data on the user account. I don't know if you know what I'm talking about.
Yeah.
Certain programs.
Yes.
Certain programs you may have to give the person temporary local admin rights to install a program because it might create another folder, another user directory when you install the program. Not sure if that makes sense.
Okay. Yeah, because I tried to turn on my laptop this morning and I VPN in, and of course my admin account that I have. I have two accounts. I have a regular user account and I have an admin account. So that admin account though is tied, I think, into something called CyberArk, which is changing my password where every 10 hours I have to log into the darn thing and get a brand new password. Quiet story. So I think it just messed around with me this morning because I was like, I thought I had that fixed, but apparently not. So I need to go back to my bosses going, I think just CyberArk, it's flipping my password to be like 10 hours. So if I go in there into CyberArk, for some reason they want us to create a temporary admin password for 10 hours on our admin account. After 10 hours is up, it gets released and then it just changes it. So I don't know why they're tying that admin account into the CyberArk thing.
I spoke to you about it. Like I would literally, if it was me and I was in your environment, I will literally look at my account and compare it to someone else's account.
I did.
And then see what's the difference between the two accounts.
The weird thing is that in my admin account, I am in no CyberArk groups. My regular account, my user account that I log in every day with on my computer, that has a CyberArk in it. So I'm thinking to myself, why isn't the admin account tied in when I'm not in any kind of groups in CyberArk? When I look in Active Directory, I pull them up side by side.
I would
up groups.
Steve, I would literally, if it was me, I would literally grab your account your regular account, your admin account, and then open up someone else's regular account and admin account and compare and contrast.
Well,
on top of that, wait. On top of that, I will go and look at the object and see where it's put in as the object of the computer and the object of the user account. See where it's put in, because the object where it is in the OU will be affecting your account as well. So you have to check that as well. You have to make sure that it's in the right OU as opposed to everyone else. It has to be on the same OU as the other people, because otherwise you have a bunch of problems when you're trying to elevate your account or do anything on your account. Does that make sense?
yeah. Okay. I can check that out tomorrow because I thought I had things squared away on Friday afternoon. Well, I guess not. Things have now flipped over the weekend again, where I'm going to walk back in and I won't have any rights. So I'm thinking to myself, why do I even have that admin account? It's not doing anything for me.
Because that happened to me, Steve, by the way.
I know.
That happened to me, Steve. I when I first started my job in IT, in this job I'm working in right now, I started my first job in IT, and I'm like, why the hell's my account not working? And then I went into I only have one account, by the way. I don't have two. I only have one account. So some companies have two accounts. So I only have one account. And then I was like, why is this not working? Then I went and I looked at my account and I saw the object, because if you do advanced features on Active Directory, you can see the objects where it's coming from. So I opened up advanced features and then I went into my account and I noticed that my account was on the OU for Windows 7. And then someone else's account is on the OU for Windows 10. And it does different permissions for both different OUs. And I'm like, can someone move me over to Windows 10? And they moved me over. As soon as I did that, I ran GP update force. I logged off and logged back in. My account was perfectly normal after that. So you have to check that.
Yeah, I mean, we don't.
And the computer too. Even my computer was on the wrong OU. My computer was on a Windows 7 OU when I have a Windows 10 computer, and the policies are not the same. So like on Windows 7, when I log in, the log off button is disabled. Task manager is disabled. Other things are disabled. Like you can't even control the power settings. You can't do anything on the power settings. And I'm like, why is it going on my account? And I noticed that it's because my Windows 10 computer is not in the right OU. So they moved me over to a different OU. I restarted my computer. I did GP update force, and then all my account was good after that. That happened to me the first couple of days when I first started IT in my current job.
You know, the other thing I can think of is that when they have me up at the Southern 10, I think that's up in Connecticut, but I believe my computer is in the Allentown OU, the all Allentown. Now, unless I would have to get somebody to do this because I can't do it. If I could move my account from there up into because I think all my mapped drives are up in Connecticut, not in Allentown. They're up in Connecticut, which doesn't make any sense. But I think I'm logging into that domain controller somewhere up in the Connecticut office, somewhere up there in Southington. It's called Southington, Connecticut. I don't know if you guys ever heard of that, but that's where I'm logging in to. Now, unless my computer is thrown in the Allentown all. And I can maybe have somebody move it. Hey, move it up there to the Southington OU. See what happens.
Yeah, because
because everything's pointing to there.
We have multiple forests in my environment. So we have multiple forests in my environment. So I have to change the forest and I have to move the computer over to that forest in my job, because if I move it over to the company that I work for, because we have subfolder companies. If I move it over to the other one, it's not going to work properly because each forest does different things. So literally, I have to go into Active Directory. I have to go to users and computers. I have to right click on domain controller and change the domain controller and drop down and click it and change it to another forest. Then I have to grab the computer that I created for a user and I have to select and drag and drop that computer over to that forest. If I put it in the wrong one, then it doesn't work. Then they start getting all these weird group policy issues where the user can't log in, the profile gets corrupted, task manager doesn't work, they can't restart, they can't log off, they can't do anything. So it's because we have multiple companies and the company has to be in the right forest. So you have to check all that too, Steven. I'm not sure if you checked all that, but you got to check all that too. As far as
kind of check it, but not check it. We'll have to wait and see. I mean, but that's a good thing. I'll have to check out tomorrow when I get in the office and see exactly where my computer is lying. Because I think we moved it over to the Allentown one. I think Dave did that for me before he left. And that's hicking it all up because all my map drives are all putting up to the Southington site, to the Southington site. And it's
Yeah.
all stuck up there. So maybe
Part-
that's why. I don't know.
Mhm.
I don't know.
Part of that too is that also we got to keep in mind that it also depends where your domain controller is located, like what state it's located and stuff like that too. So you have an issue where the domain controller is located somewhere else, and then
Right.
people ask me like, Kevin, why am I having this issue where I connect to VPN and it's very slow?
Right.
It's very laggy and slow, and I'm like, no, it's because you're in New York,
Right.
and VPN is running from Texas, so there's a slight latency between New York and Dallas or whatever because of that. So people have been asking me that, and I'm like, our VPN goes into New York first, it goes to Dallas first, it goes there, and then connects back to New York. So that's why it's a huge delay when you're trying to download files and you're moving files over on the shared drive and all that good stuff. So
Okay.
you got to check all that too.
Well, I mean, somebody in the sysadmins group over, they need to rip into my account a little bit and see what's going on. And hopefully I'm getting closer. Just I'm missing something yet. Getting closer. I thought Friday I had it all figured out. I'm like, yay, I can actually work. And all of a sudden today I'm like, nope, it's something now is blocking it. So I gotta figure this out. All right, thank you. Go ahead, April. Sorry for hijacking. Go ahead, go.
No, hijack all you want. I think we're all learning.
Me too.
That's where I do, like, if you do Exchange 365 or you do Exchange and you do advanced features on Active Directory, I use attributor a lot. You know, the attribute button on Active Directory, I use that a lot.
You mean the attribute button?
Yeah, the attribute button. You know what I'm talking about?
Yes, kind of.
I use that a lot, and I manipulate the SMTP, the email addresses and stuff like that. I manipulate that from a server perspective. I have to change that sometimes when I'm creating some of these accounts.
It seems like they're not going to allow us to even touch servers there, let alone Active Directory. It's hard enough to just get my fingers on that. It seems like they have it all scattered about in the world, it seems, and I just want Active Directory access so I can move things around. But the big thing is my password, because I think that kind of jacked up my VPN this morning too. I was like, what the heck? I'm like, it changed. And then I couldn't get on. I'm like, ugh, everything is so damn tied into that. It's driving me nuts.
What's the password retention? You said every couple of hours? That's crazy.
It's 10 hours for this thing called CyberArk. And there's this thing called CyberArk out there. And apparently my user account is tied into that. The admin account, I'm in no groups for CyberArk whatsoever. But for some reason, they want us to go into the CyberArk to change our admin account password every 10 hours. Which doesn't make any sense.
Okay, bro.
Anybody want a kid? Cheap?
Is that because of a security thing, or?
Send him over my way.
I'm thinking it is, and I don't know why they put us in there with it. I could see other people, but I can't see.
I'm not gonna listen with a kid crying in the background.
Yeah, he's trying to do a train on a blanket, and it doesn't work because the tracks fall apart. He has to learn that. He's learning the hard way.
Yeah, he left. He got frustrated with the noise.
I don't understand. Children are children. Hi, Danish.
Oh, Danish, he got the fresh cut and he's driving. Oh my God.
How are you guys? I am actually waiting for my pizza. Okay. I'm sorry to jump into your study guide, so I was
No, it's okay.
What are you guys covering? I just
pizza. Covering pizza today.
How to make pizza?
Yes.
Danish, we did the OSI and TCP IP model video. We did hub switch routers explained, Ethernet cables, UTP versus STP. We did half duplex versus full duplex, and the next one we're gonna do is CSMA CD and CSMA CA explained.
That's awesome. I think the the good thing about these videos are they are from a channel where they do like they do visual show, because it's really hard to explain this stuff in a normal text version of or diagrams. So I think that channel is really good. And this information is really good for people when they have a little core understanding. You don't have to really master none of this stuff. As long as you know the basics, it really helps you to when you go to the network. And just like when I was teaching you how to create a whole domain controller, you don't touch domain controller, but now seeing that domain controller getting created by you, it just makes your job very easy. When you create the username in Active Directory, you know how this house was built. So when you know the house was built, it's really easy for you to understand or comprehend that, when you have this issue going on, it's easy for you to go after it. But again, my recommendation to people with this is when you guys are doing that is that, don't try to master this, because you're not going to be able to do that, right? But try to understand it with so many professionals that are sitting right here, like Steven and so many other Raj, and try to get more understand the overall understanding of this is going to really, really help you in future. And I think you guys are doing a great job by doing this whole thing, because it's just, not many people go over it. I even tell people in my live training that make sure you guys go over this before take our live training, but they don't. Oh, my brother's coming right now, so I'll just pause for now.
Thank you, Danish. But yeah, I agree. I mean, I did it before the live training. I don't know if I did. Yeah, I did all of the course stuff. And like I said to like everybody yesterday, I learned a lot. So when I first watched it, I was like, what are they talking about? I have no idea. And then when I'm watching it like today, I have more of an understanding. I'm not comfortable enough explaining it to people because I'm worried to explain it incorrectly. But when you rewatch it like a few months in, you get like a better grasp of like what everyone's talking about. So let's go to the next video. Hold on, please. Please hold. System processing. Also, for anybody
Good morning.
who, let's go. For anybody who wanted this channel's information, I'm gonna link it again in the YouTube chat. I really like this channel too. He explains things really, really well. So let's do this.
Project Pandora's box is back.
No!
Guys, it's just a box.
Have you ever wondered how computers send data on the network without interfering with the data from other computers? Especially if the network has a lot of computers that are sending and receiving data at the same time. I mean, you would think that there would be a lot of collisions happening. I mean, there should be data packets that are constantly smacking into each other in all that network traffic. But even though collisions do happen from time to time, especially on older networks, a technology was developed to not only help avoid collisions, but also to respond correctly if a collision does happen. And this technology is called CSMA-CD, which stands for Carrier Sense Multiple Access Collision Detection. And this is the access method used on early Ethernet networks. And when I mean early, I'm referring to half-duplex networks that utilize coaxial cable and earlier versions of twisted pair cable. Now, CSMA-CD basically works by each computer first sensing if the wire is idle. And if it is, it sends its data, therefore avoiding any collisions. But if you have two computers trying to send data at the same time, a collision will happen. And if a collision happens, the computers will wait a random amount of time and retries to send their data. So as an example, here we have a network with 4 computers, and these computers are all sharing a common transmission medium, which is a cable. And this cable must be regulated so that no computers send data at the same time, which would result in a collision. And when a collision happens, it causes data loss or data corruption. So let's say that this computer here wants to send data. So first it will sense or listen if there is any traffic on the cable. And if it senses traffic, the computer will wait until the cable is idle to send its data. But once it senses that there is no traffic, it'll go ahead and send its data. And as it's sending its data, it will listen for a collision. And if it doesn't sense a collision, it knows that the data was successfully sent. Now, in another scenario, if two computers are ready to send their data and they both notice that the cable is idle, then both computers will go ahead and transmit their data at the same time. But when this happens, a collision occurs. And when the computers that are sending the data detect a collision, they immediately stop sending the data and instead will transmit a jamming signal out on the network. And this jamming signal is what notifies all the other computers on the network that a collision has happened. And after the computers receive this jamming signal, the two computers that cause the collision will wait a random amount of time before they send their data again. And the wait time must be random to each computer so that the collision doesn't happen again. So as I stated before, CSMA-CD was used on early Ethernet networks, and it isn't as relevant today due to the advancement in network technology. It was only relevant in the older half-duplex networks, where data communicates in both directions but not at the same time. Today, we use full duplex networks, where data can communicate in both directions at the same time. And there is also CSMA-CA, which stands for Carrier Sense Multiple Access with Collision Avoidance. Now this is the access method that's used for carrier transmission in wireless networks. Because just like wired networks, wireless networks need to avoid collisions as well. So this is how it works. So when a computer wants to send data on a wireless network, it really can't sense or hear if there are any collisions on the network because there's no cable involved. So instead, it does its best to avoid collisions altogether. So in this method, when a computer wants to send data, it'll first sense if there are any other transmissions happening. And if it detects any other transmissions, it'll wait a short amount of time before checking the channel again. And when it checks the channel again, and if it doesn't sense any transmission, it'll wait a short random amount of time, and then it'll go ahead and send its data. Then once the destination device receives the data, it will respond to the sending computer with an acknowledgement, informing the sender that it has received the data. But if the sending computer does not receive an acknowledgement from the destination, it will assume that it did not get the data and it will start the process all over again. Now, another method that CSMA-CA uses to avoid collisions is the optional RTS-CTS protocol, which stands for Ready to Send, Clear to Send. Now, this is an optional protocol that's used with CSMA-CA on wireless networks. This protocol enables a computer to send out an RTS or ready-to-send signal to the wireless access point requesting for an opportunity to send out its data. And if the wireless access point grants this request, the access point will temporarily stop all other communication on the network, and then it'll respond back to the computer with a CTS or clear-to-send signal, which tells the computer to go ahead and send its data. So in this protocol, the wireless access point is basically the traffic controller on the wireless network.
Let's move on. For everyone who doesn't know, what the plan is to kind of go over these hopefully daily or something like that. And then like make quizzes at the end of the week and quiz people and do labs and things like that, so we can, of what we learned in the week. Oh no, we have a problem. Let me try to fix this. I don't know why it does this. Hi, Steven. Is he mad at you?
Yeah. I'm just tired.
It happens. That's the YouTube channel that we're watching the videos from, you guys. Okay, wait, it's working again, so let's go back down.
For the people that are watching, does any of that stuff you guys have saw make any sense to you at all? Or is that the first time you're kind of seeing that?
I've seen this before, but I don't know about everybody else.
Yeah, his videos are pretty good.
Yeah.
That guy really knows his stuff.
Mm-hmm.
He explains it. I think he's from.
He explains it really well.
I think he's over in Britain. He's over like in Europe or somewhere like that. I've seen a picture of him one time. He kind of looks like a really geeky guy. So he must be
Yeah,
really.
really? I wouldn't have guessed.
Huh?
I wouldn't have guessed.
Yeah. He's like I'll say he's maybe in his 50s or early 60s, I would think. He's up there. I think so.
All right, time for TCP versus UDP comparison.
Whenever a computer wants to communicate with...
I'm just kidding, you guys. 1 second.
another computer, the communication between those two computers needs to be good and reliable so it can guarantee that the data is received correctly. For example, when you want to view a web page or download a file or look at an email, you'd expect to view the web page intact and in order with nothing missing. Or if you're downloading a file, you would want the entire file and not just a part of the file. Because if data is missing or out of order, then it wouldn't be of any benefit to you. So this is where TCP comes in. TCP stands for Transmission Control Protocol, and this is one of the main protocols used in a TCP IP network. And TCP is what is used to guarantee that all the data is received and in order. Because without TCP, then some of the data could be missing or out of order. Because if you view a web page without TCP, your web page could be all messed up. The images could be missing, or the text could be backwards and out of order. Or if you download a file, then you might not get the entire file, or you could get the file out of order, which would render the file useless. So again, this is where TCP comes in. Now, TCP is a connection-oriented protocol, which basically means that it must first acknowledge a session between the two computers that are communicating. So the two computers verify a connection before any communication takes place. And it does this by using a three-way handshake. So the first step is that a computer will send a message called a SYN, S-Y-N. Then the receiving computer will send back an acknowledgement message telling the sender that it has received the message. And then finally the sender computer sends another acknowledgement message back to the receiver. And then once this has taken place, data can be delivered. Another important thing to remember about TCP is that it guarantees the delivery of the data. So if a data packet goes astray and doesn't arrive, then TCP will resend it. Now UDP is very similar to TCP. UDP is also for sending and receiving data, but the main difference is that UDP is connectionless, which means that it does not establish a session and it does not guarantee data delivery. So when a computer sends their data, it doesn't really care if the data is received at the other end. And that's why UDP is known as the fire and forget protocol, because it sends data and it doesn't really care what happens to it, as this demonstration will show. Another point to remember is because of the less overhead that's involved of not guaranteeing data delivery, UDP is faster than TCP. So thank you for watching this video on a comparison between TCP and UDP.
Well, I thought that one was pretty cool, guys. If you
Yeah.
kind of understand that a little bit. When you look at the TCP IP protocol, if you think of it this way, the TCP sits at it's on the transport layer, okay, for TCP transport control protocol, so think of it that way. It's on the transport layer of the OSI model. But then you got the actual IP part. So the IP part, when they talk about TCP IP, the IP part is what makes the connection between your computer and the other computer. And then the TCP part is that transport, is what transports the information back and forth between. You can also, during that, remember yesterday's, whoever was on, I talked about windowing. The windowing process happens at that TCP part where it sends one packet. So one packet will be sent from client to server. Let's say I'm going from the client to the server. It's going to say, oh, did you get that? Yep. Okay. All right. Now I'm going to send you packet number 2, like 2 packets. Did you get that? Yep, I got that one. How about 3 packets? Yep, I got that one. Then it's going to start to send chunks out. Let's say you get the packet 5,000 and whatever. And it says, oh, I did not get packet 5,000. Okay, hold on a second. It's going to go back to TCP going, hold on, let me start this over again. Did you get packet 5,000? Yes. Okay, now we can go 5,001, okay. 5,002, 5,010, 5,000, and it'll keep, that's where things can pick back up. That's why when you see it downloading like that, like back in the day, when we had like 28K modems, if anybody, 56K modems, you've seen this a lot. With something, if you had a progress bar on, if you saw that gray bar or progress bar going across the screen, you see it like jittering up and lower, and it's kind of like going in and out. That is windowing, and it's a very, very important part of the TCP protocol. But that's something that you guys should get to know. And of course, UDP, they just explain. Hey, you didn't get packet 5,000? I don't care. I'm sending you packet 5,001. And I'm going to keep on going until I'm done. I don't care if you lost some frames along the way. Who cares? But you got the information as fast as I could give it to you, and that's what you want. YouTube does this as well. You can see the frames drop. When you're watching YouTube, you can go on like statistics. You can actually see some frames are dropped on the video, but you would never notice those frames. I mean, your eye is like, oh, all right. I saw Hifa's video, but I may have missed 2 frames. You're not gonna be able to pick that up.
Okay, I see what you're saying.
So you kind of like have that ability to see that in action too as you're watching a video. You can see frames being dropped and stuff like that. So other than that, it's very important to understand.
It is. Thank you for explaining that, Stephen.
Yeah.
I think I'm gonna do one more. Because then I need to go take care of my dog. He's being naughty. But we'll most likely be on later, hopefully, to do the packet tracing. Let me do this.
Annette, that groundhog's back. He's walking towards the door. Look at that. I guess it's Groundhog's Day in more ways than one, right? Did you?
An IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. The IP address consists of two parts. The first part is the network address, and the second part is the host address. There are also two types of IP addresses. The first one is the most common one. It's called IP version 4. And a second type is IP version 6. IP version 4 is the current version of IP addresses. It's a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods is called an octet. The number range in each octet is 0 to 255. This address version can produce over 4 billion unique addresses. In the world of computers and networks, this IP address in this format here is meaningless. Computers and networks don't read IP addresses in this standard numeric format, and that's because they only understand numbers in a binary format. A binary format is a number that only uses ones and zeros. The binary number for this IP address is this number shown here. This binary number is what computers and networking devices actually read. So the question is, how do we get this binary number from this IP address? IP address 4 is made up of 4 sets of 8 binary bits, and these sets are called octets. The bits in each octet are represented by a number. So starting from the left, the first bit has a value of 128, then 64, then 32, and so on, all the way down to 1. Each bit on the octet can be either a 1 or a 0. If the number is a 1, then the number that it represents counts. If the number is a 0, then the number that it represents does not count. So, by manipulating the 1s and the 0s in the octet, you can come up with a range from 0 to 255. So for example, the first octet in this IP address is 66. So how do we get a binary number out of 66? First, you look at the octet chart, and you would put 1s under the numbers that would add up to the total of 66. So you would put a 1 in the 64 slot. So now you already have 64, so we need 2 more. So let's put a number 1 in the 2 slot. So now if we count all the numbers that we have 1s underneath them, you would get a total of 66. All of the other bits would be zeros, because we don't need to count them since we already have our number. So this number here is the binary bit version of 66. So we'll put that number down here. So let's do the next number, which is 94. So let's put a 1 under 64, 16, 8, 4, and 2. So if we were to add all the numbers that we have 1s underneath them, we would get a total of 94. And since we don't want to count any of the other numbers, we just put zeros under the rest. So the next number is 29. So let's put a 1 under 16, 8, 4, and 1. And when you add all the numbers up, you get 29. And our last number is 13. So let's select 8, 4, 1, and when you add those up, you get 13.
Dad? Hey Google, what is the highest mountain in the world?
Mount Everest at 8,848
Mount Everest, I
meters.
think.
K2 at 8,611 meters. And
K2
8
would
others.
be the second largest one, hence K2.
When the internet was first developed, programmers didn't realize how big it would become. They thought that IP version 4, which produced over 4 billion addresses, would be enough. But they were wrong. IP version 6 is the next generation of IP addresses. The main difference between IP version 4 and IP version 6 is the length of the address. The IP version 4 address is a 32-bit numeric address, whereas IP version 6 is a 128-bit hexadecimal address. Hexadecimal uses both numbers and alphabets in the address. So with this type of address, IP version 6 can produce an unbelievable 340 undecillion IP addresses. That's the number 340 with 36 digits after it. So as you might have guessed, IP version 6 is more than enough for the foreseeable future. So as stated before, IP version 6 is a 128-bit hexadecimal address. It's made up of 8 sets of 16 bits, with the 8 sets separated by colons, as you can see here. So in a similar way that we converted an IP version 4 address to a binary number, this is how we convert a binary number to a hexadecimal address. In an IP version 6 IP address, each hexadecimal character represents 4 bits. So we have to convert 4 bits at a time to get one hexadecimal character. So starting from the beginning, we convert the first 4 bits and put those bits up there against our 4-bit chart, which includes an 8, 4, 2, and a 1. So if we count the numbers that we have ones underneath them, you wind up with a 2. So a 2 is the first hexadecimal character in this IP version 6 address. So let's do the next 4 bits and put those under our 4-bit chart. So if we count all the numbers that we have ones underneath them, we have a 4 and a 2. And if we add those up, we get 6. So a 6 is the second hexadecimal character in this IP address. So let's do our next set of 4 bits. And if we add all the numbers that we have ones underneath them, we get a total of 13. But the problem is, since 13 is a double-digit number, we cannot use a double-digit number to represent 4 bits. And that's because in a hexadecimal format, double-digit numbers have to be represented with a single alphabet, which is A through F. So in this case, we have to use another chart for any 4 bits that the sum is 10 or higher. So in this chart up here, if the sum was 10, then we would use the letter A. Or if the sum was 11, then we would use a B. But in this case, our sum is 13. So now for the third character in our binary number, we would put a D. So in our last example, let's do the 4th set of bits. And if we add those up, we get 11. So we have a double-digit character again, which means that we have to convert it to a single character alphabet. So if we look at our chart up here, 11 converts to a B. So the first 16 bits of this binary IP version 6 address converts to the hexadecimal address as 26DB.
Do you guys feel like that was, he explained it well and it was easier to understand?
Is everybody's head just exploded? That's hard. That is not easy.
He explains it really well.
He does, but it's still very difficult to learn that. And get this, guys. I mean, that video was probably shot more than 5 years ago. I bet you, if you take a look at the date on his website, on the guy's real website, And 10 years ago, Eli, the computer guy, said that IP version 6 is out there. People are going to it, but you probably won't. And he said it in his, because I actually watched a video yesterday. He said that IP version 6 may be coming around in 2020, 2021, 2030. And that was 2010 when he made that video. And because of network address translation, that is why IP version 4 is still popular today. And nobody has gotten on the, we are slowly getting on the IP version 6 bandwagon, but it's a very, very slow roll. Very slow roll. Because that is for, I'm terrible with math. Anybody who's terrible with math, just getting a grasp of IP version 4 is hard enough. Version 6, if you're good with math, no problems. You can kind of figure, you can kind of figure things out. But they're all like little tricks in there too with double zeros. You gotta do like all kinds of weird stuff in there. So there's other things which he didn't gloss over, but it is tough. I mean, that's why, thank God, IP version 4 is still around, and we can just go 4 numbers, you know, and take it that way. Because version 6 is hard. Unless, hey, are you good with math?
I am not good with math.
Okay. So
yeah, I can do IPv version 4 pretty easily. But as soon as it comes to 6, I'm like, I don't speak English. I don't speak numbers.
and he also didn't explain too what's the host and what's the network.
Huh?
So network and host on there. You know what I mean, in that address. So he didn't even gloss over that either.
No, he didn't.
I guess there's classes in IP version 6. I'm not sure.
Oh,
Unless there isn't, because I think the number is the number. I don't think like, I think that number is a number because everybody will have a single number instead of a class. I think there are no classes in IP version 6. 4 there is A, B, and C, D, E. But I think in version 6, I don't think there are classes because there are so many addresses. Everybody will have a single address in the world, like your house number.
So classes are not needed.
Yeah. So that's, but what, do you know, did you read in there like what separates the, I guess there is no network and host, is there?
For IPv6? I don't know.
Yeah, there's gotta be something.
I don't know
Right?
anything about IPv6.
What was that, Hepa?
Oh, excuse me. I said I don't know anything about IPv version 6.
Okay. Yeah.
IP,
Neither do I.
why do I keep saying IPv version? IPv6.
Yeah.
Sorry.
Neither do I really. That's beyond my. I'm terrible with math. Like I can add one like plus one. So when it comes to that stuff, I was always like, what? Just never really settled in. Oh, that's good. You know, it's but it is what it is. But 6 is out there. I mean, when you guys do your IP config, you guys see your version 6. They are slowly rolling it out. But I think because of network, I mean, what saved IP version 4 was network address translation built into these routers at home. That's why we all have 192.168.1. whatever. And at home, it takes that, you know, it takes that public IP address and turns it into a private IP address, and then you can share it on out to your networks. So thank God for Mr. NAT, because if not, then maybe we would have ran out, but they thought that we would have by now, but we haven't. So because of NAT, I think it's saving it. I don't know how long, maybe the next 10 years from now, you know, if we're all still in this, we can say, hey, yeah, IP version 4 is no more.
10 years? No, I was only gonna do 3 more, you guys. Just kidding. But yeah, that's really good info. I think I'm gonna have to stop for today. I really have to go to the dog before he eats me. But I think what we're gonna try to do is be on later and do packet tracers, or maybe it won't be like the official upload. Maybe we can just all mess around with it as a group. I'm thinking after 7 p.m. Eastern Standard Time. It is almost 3 p.m. Eastern Standard Time, so please do your math on your side of the world. And yeah, thank you guys for being here today. Stephen, thank you for, well, thank you to all the pros who are here today, but thank you, Stephen, for like chiming in and like adding like fun facts and stuff.
Yeah, I was gonna say, just hit me up or something like that. Just let me know what time in case I get involved with Mr. Troy here or something. We can, then I feel we
I think it's definitely going to be after 7.
Okay.
Since most of the people that want to do this are here, are you guys good with, nope, no English, hold on. After 7 p.m. to do the packet tracing?
Yes.
Yes, okay.
That'd be kind of cool to see because I mean, I've seen it done. I've seen packet tracer, but I never really.
Let me upload the topology diagram for the packet tracer so you can see it. Then I will.
I'm sorry?
Let me see.
What was that again, Philip?
I said, let me upload the topology diagram. Then with the scenario.
I haven't even opened the program file yet. So I really haven't done, it might be like a bunch of us just playing around with it and trying to figure it out. I literally
Tech has played around that a little bit. You might want to maybe shoot him an IM or something like that and say, hey, do you want to hop on? And maybe, you can show us. Huh? Well, Donish, I'm sure has, but I mean, KevTech also has it. Yeah, KevTech has it on his PC, I believe. That he downloaded it and he was playing around with it. So I'm pretty sure he was playing around with it. The Cisco Packet Tracer, I think what the application was. So he may
Nick was actually kind enough to send it over to me.
Okay.
But yeah, I'll message KevTech and see. I know he went for listen, I don't promise anybody that we're gonna learn anything about packet tracing today. I just promise that we're gonna open it and look at it. If we can figure it out, that would be great. Trial and error. So don't come in expecting like an actual lesson or anything. We do plan on doing that. Just if you guys want to do that for fun today, like just kind of learn together.
I think that's where maybe Kev might, if he's willing to come, hop on for a little bit.
I'll talk to him.
Show something because he's played around with it. I never really played around with it. I never went down that route yet. I've seen videos on it. It's pretty cool. You can create your own little, environment, make it look like a real, go into the CLI and, activate a port, stuff like that. We might have to do some Google searches on how to, activate it, but, stuff like that. But maybe Kevin might have done that already.
Okay, I'll message him and see what he says.
Yeah.
Okay, everyone. Thank you so much for being here.
Okay.
Thank you to everyone who's been supportive throughout my baby YouTube channel, not actually a YouTuber.
Thank you for having us.
I already gave it a thumbs up.
Oh no, you don't have to do all that. Hold on, I need to save this file from Nick. Okay. I will talk to you guys later on Discord. I need to drive over to the dog.
All right.
Oh, okay. Nick sent me the basic topology. Okay, cool. I will look at it when I come back to the house. But let me go be with him. Thank you all again. I will talk to you soon. See you on Discord. Goodbye. Goodbye, everybody. Thank you.
Ciao.
Bye.
Bye. Yeah.
Au revoir.
It's
Ta-ta.
the way. Bye.
Bye.